Welcome to Taiwan Innotech Expo. Innotech Expo 2022 is held from October 13 to October 15. For these 3 days, come to Taipei World Trade Center. We are going to showcase a lot of front-hat technologies and innovations, from smart technology, smart manufacturing, smart medicines, or even smart agriculture. Or even when you come here, you are going to see some national defense and intelligence showcase here. And a lot of new models or new technologies are here, covering from every aspect from 10 different ministries in Taiwan. And first of all, let's come to this international technology, the Industrial Technology Research Institute. So they are already revealing different new technologies. So first of all, please say hi to our audience and also have a brief introduction to us.
Okay, hi everyone. I am the company NanoCX. We will be spin off in the future. And what we are building the technology is basically on the X-ray technology.
Okay.
And why we have this marketing demand is basically from the 2 nanometers process in the whole world. We know that from 3 nanometers to 2 nanometers, they have been a more complex structures like 3D structures, but the traditional tools cannot measure them now. They have some sensitivity problems, so they asked us to build up the X-ray technology, and this is a trend in the whole world. And we can measure the berry structure and also the 3D XYZ dimensions, and it has a very good precision right now.
So
Yeah.
what specific industry or field would this be using for?
Basically, they will be using in the semiconductor, in the high-tech front-end semiconductor fab, or some kind of memory, because we know that memory they use 3D NAND also will have a 3D complex structure,
Yeah.
and they will be interested in using our technology too.
Yeah, so we all know that, for example, like TSMC or
Yeah,
this type of
yeah.
huge giant companies are based in Taiwan, but already produce and have influence in the whole world.
Yeah,
so
right.
these breaking through technologies, innovations would make some very huge difference to it, right?
Yeah, right. There were basically some demands is from the T company, of course.
Right.
And maybe in the future, we know that Samsung and Intel will maybe have interest in this, because we know this kind of 2 nanometer process will be using the 3D structure in the future and maybe so long.
Right. So is there any demonstration here that you can show for the audience to talk about the breakthrough?
We can see that from this picture is in our laboratory, is our prototype. This prototype is much smaller than this one now. This one is the alpha tool we built it and it's ready for demo. And what is kind of different is that it is for the technology verification, and we have also showed the results to our user, and they were very satisfied. And this alpha tool are also built in our laboratory, and also is ready for demo and also be seen by our user. And we are now waiting for the samples to our laboratory to test.
So any expectation date for 2 nanometers to put in practice?
They are still in the R&D site,
Yeah.
and maybe we hope our tools will be sent into the user side around 2024.
Okay.
And then they will be used, they will have a mass production in 2025. So this is a very tight timeline, but
Yeah.
we are trying to get to it. Yeah.
Welcome first to OmniMeasure, and then I am Murphy, and I'm going to introduce to you our current company technology. Now, right now, this is for the future of semiconductor, because of Moore's law. As the chips are shrinking in size, they're requiring vertically integrated circuits, and then consumer electronics with medical and also aerospace. They're all trying to aim for these power efficiency, higher efficiency, more functionality, also with lower power reduction. So with this, our technology is actually for the inspections of vertically integrated circuits. Now there's 2 methods, which is right now for wafer bonding, which we're the chips are growing tall like a building and the wires are coming out. But this has a limitation due to the wires coming out. So through silicon via technology, which is a bunch of little holes, if you can imagine these shrinking into a much smaller size and then digging through. So in a building, it's like an elevator.
Yeah.
Now we want to have these fill with copper to have the electricity pass through instead of coming out. So this is where our technology comes in. It is a $4 billion industry in 2016 and now making its way to 2023 at $10 billion. So our aim is to give you the depth information so you know when the wafers are made, how deep are these holes. So right now in our system, we actually have a little chip here, and then you can kind of see this complicated little screen. But actually what you want to know is how deep it is. So we just look for this peak, and it tells you, oh, okay, right now it's 79 micrometers. Right? And then this is actually the viewing port. This is our just our hand-on stage, and we're working our way to make a 15 wafers per second inspection system, fully automated. Right? So these are 5 micrometer holes. So you can see in the industry right now, mostly are using aspect ratio, which is the ratio from the top critical dimension to the depth of 10 to 1. And then we can also do 15 to 1. And our goal is to measure up to 20 and 30 aspect ratio.
So as you know, the Infineon is the top one, the number one in the automotive, power, and also the IC market share.
Yeah.
And the other one is very outstanding, the market share in the power discrete. This kind of the application is the TOF. So it's kind of the 3D sensing module. So it's a very tiny camera modules. So it's not only the 2D, it can detect the 3D. And in this environment, Infineon will need to partner with a lot of the talent companies, a rising star company. Like the first one is the Fabrication. They can help us to complete all the algorithms and also the applications. To use this camera to have AR, VR applications. Yeah, so this is one of the TOF, time of flight applications. And the other one, we have also engaged with one of the Taiwan talent company called Asuka. So partner with them, we are providing the radar and also the CO2 sensor. This is also very quite new and very innovative sensors to work with them. So they can complete some of the very useful application to promote to the market.
The radar can detect the object which is approaching or departing. And when approaching, the red light will turn on. It can use in like detect the car or detect the human, and also it can send the data to the cloud. You can see here the motion is triggered. Okay, and this one is an environmental sensor, includes CO2 and temperature and humidity, and it can sense real-time sensing the value in the buildings. So you can see here the CO2 value and the temperature and humidity, and the historical profile here. So okay, that's all.
In the past time, we are quite proud of selling the semiconductor and also the technology. We are the first one to realize the production of the 300 millimeter wafer in the power semiconductor.
Right.
And not only this is wide band gap. This is the third generation of the semiconductor. So outside this one, the digitalization, we are also focusing on loss sensor and system solution development.
If we've got big structures, we make every time the same thing.
Okay.
We grow metallic turf structure directly on the pad, and then we stick them together and make a mechanic fast millisecond process joining out of pure copper, pure silver, gold or nickel. So I lay it inside, one on the downside, the other on top.
we bring them in the right position, and then the only thing what I do is I press them together. And during milliseconds, now we weave the wires in each other and make an ideal electrical and thermal contact. We open it again, and now we made the joining. And this in a size of 3 micron pads or 300 millimeters. And now I need your help, because now we make a metal joining test. Please take the one side, look to her face, and now just like a towel. Very strong, strong. Ah! So it's no, again, come on. Really. Ah! So it's a contact in a tightness that you now can directly make the next step in your production line. And this after milliseconds, but it is repairable. So please break it. Damage this nice contact by torsion. So yes. So if you know how to do, you can break it. So it is the final tightness comes after 12 hours. But if we make it with additional heat, and now I just make a small miracle. Now we've got an additional part, and this part, you see, has a special preform element in between, because this had no hairs, because you broke all hairs. I needed to repair, and now again, first the towel test. Come on, give me all your energy. Okay, and now you're allowed to break it. And look to her face, please. Please more.
I
more.
don't think this one would be easy.
We need more energy.
Oh, I think I bent it.
Yeah, excuse. So we call you Uri Geller. So
What's that?
it's Uri Geller is a person who brings spoons bended.
Oh, okay.
So it's no more possible to damage the joining. So this joining has a force level of 50 megapascal. So, and this is a sintering process at 170 degrees. So if you compare it to silver sintering, for example, this plays in a leak of 240. We are copper pure at 170. And this is a new technology to make 2D and 3D integration processes on 3 micron up to 300 millimeters.
That people probably know silicon carbide, gallium nitride.
Okay.
Traditionally it's a silicon, but now it's totally different materials. And we can apply that kind of material to make a very high efficient power conversion.
Okay.
Right now, this unit is 99%, and at the same time we push to 11 kilovolt, 100 kilowatts.
And it's already put into practice, or
Yes, already tested.
Okay.
We already fully tested, 100 hours, very reliable. Because it's so efficient,
Right.
there's no heat, no thermal stress.
Okay.
The transformer inside, that's a little tiny 3 kilowatt transformer.
Yes.
You can put it in my pocket.
In the pocket, right?
Yes,
Pocket
but
size.
traditionally, our 60 hertz transformer, like this one is actually 4 kilowatts. 60 hertz would be 40 kilograms. You think about 40 kilograms is how heavy, and this is big.
Mm-hmm.
And now this one you can put it in the pocket. We use this kind of step. Traditionally, is a pulse width modulation, which use switch very high frequency. So every switching is a loss, and we don't have switching loss because it's a very, very low frequency.
Okay.
And we just stack up different level of voltages because we isolated with wide bandgap devices technology.
Mm-hmm.
And so we can stack it up and stack it to 11 kV, 22 kV that we can directly apply to the utility. For example, high power.
Okay.
Yeah, 99% efficiency.
Paragraph has perfected
the capability to deposit contaminant-free 2D graphene at wafer scale and be able to do that in volume. So when I say that we have volume manufacturing capability for 2D graphene-based devices, I mean we also have our own fab and the ability to produce graphene-based devices in volume. So essentially, it's this kind of device that's shown here in the screen. So this is the chip that is being used for magnetic sensing and current sensing. It's going into some very important and impactful, for example, electric vehicle applications for battery management.
Right.
But there's a whole host of really impactful applications that this kind of new form of 2D graphene-based sensing can help with. The other aspect of graphene is that it's biocompatible. So this is opening up a new horizon in clinical diagnostics, a potential to begin to enable faster diagnostics, lower cost, for more people saving more lives.
Right.
So we're very interested in how we can bring 2D graphene to help with those kinds of global problems.
Okay, so would it cost less or actually create more values? That's the key.
I'm sorry?
Would it cost less or create more values for this type of energy
it would really help to kind of democratize diagnostics. This is the long-term view where it will be much more cost-effective, much faster, and more available to more people.
Hello everyone, my name is Camus and we are to share solutions. So what we did is a tactile sensor on the industrial robot. So if you look at the screen, we are E3-based technology team, and it was founded in more than 10 years ago. But in 2017, we spin off from E3, and we announced the first T-skin, tactile skin for industrial robot in 2018. Then we delivered the Taiwan's first collaborative application in KISTA with ABB's robot. Imagine if we can easily upgrade our industrial robot to perform tasks safely together with operator.
Right.
Then all the automation will be different because we can provide flexibility and more image for application. As you can see, actually a skin for robot can be very sensitive, so it can prevent the egg from being broken.
Oh, okay.
So yeah, it's a very cool and a very new area for sensing technology, especially for Taiwan. We have a good ICT infrastructure, so we can provide this kind of solution for all the robot users. So
actually, we can see sensors here, right?
Yeah, under the cover there are a lot of tactile sensors. So when you touch it, you can see there is a red line, which means it's on normal contact. Actually, if you just smoothly touch the arm, the robot can still working. But if there's any abnormal contact, the red line will trigger the emergency stop to stop the robot immediately. We have a lot of we have a rich portfolio of different kind of skin for all industrial robots, from Scala robot to 6-axis arm robot.
So this is the traditional one without the T-skin, right? But with your advanced type, there's
so
T-skin on it.
The concept is very simple, just like you have your
The
own
phone
cell
case?
phone, then we have a functional case which can open the gate to bring the industrial robot to very close to people. Yeah, that's our idea.
So for our audience online, this is for today's live streaming, and actually you're still very welcome to come visit the expo for today and also for tomorrow, because today we'll still have the expo until 5 p.m. and tomorrow we start from 9 until 5. So still one more day to go, and we hope to see you here at Taipei Innotech Expo. I'm Gladys. Thank you for staying with us, and see you next time.